Hey guys, this is the last lesson in this unit, and we're going to talk about exponential equations. An exponential equation is an equation that contains a variable in the exponent, and these are just some examples. So like 2 to the x equals 32, that's an exponential equation. 9x plus 1 equals 27 to the x, that's an exponential equation. And then this last one is an exponential equation. I'm going to show you how to solve some of these. And the strategy we can use to solve them. Some exponential equations can be solved by writing both sides of the equation as powers of the same base. So for example, this one up here, 2 to the x equals 32. You can also write 32 as 2 to the 5. So that would be writing it so that they're in the same base. Which then means that if a to the m is equal to a to the n, where the bases are the same, then m and m must be equal to n, so m and n are the same. So in this case up here, if it's 2 to the x equals 32, which is 2 to the 5, then I can then say that x must be equal to 5. We're going to do a couple different examples of finding a common base and solving for different examples, and we're going to start really easy and do something a little bit more difficult, and you'll see how we do that. So I'm going to move the page down. First one's really simple. 5x equals 5 to the 6. We already have it so that we have the same base, so that just leaves us to say, well, if that's what it equals, then x must equal 6. So you can just drop the base once they're the same. B, 2x equals 32. We sort of already did that up above. So again, we put it in the same base, and then we can say x equals 5. C, we have 3x minus 4 equals 49. So I start to think, what is 49 if I put it into base 7? 49 is 7 squared. So I'm going to change that 49 to 7 squared. Now that we have the same base, what I usually do is I drop the base and I just get rid of it, and I'm left with 3x minus 4, because that exponent must equal 2. And then all we have to do is solve for x. So I'm going to move that 4 over. It's minus on this side, so it becomes plus on the other. So 2 plus 4 is 6. And then I'll divide both sides by 3. And I get x equals 2. D, 3 to the 5x plus 8 equals 27x. So we're going to do the same thing here. I'm going to change that 27 into a base of 3. So this will still stay as 5x plus 8. 27 to the 3 becomes 3 to the 3. And we also have the x there. Let me just show you sort of what happens here with the rule. Is it sort of becomes 3 to the 3 to the x, and then our power rule says that that's 3 to the 3x. So now we've got the base the same, so I'm going to drop it. I get 5x plus 8 equals 3x. I'm going to move the 5 over. So it's going to become minus 2x. I'll divide them both by minus 2, and I get minus 4 equals x in this case. Last one, E. 2 to the 2 x minus 5 for 3x minus 1. So again, I'm going to change that 4 into a 2. equals 2 to the 2, 3x minus 1. So I have to multiply that one out. And I do have to multiply this one out as well. So I'm going to make it 2x minus 10 equals 2. 2 times 3x is 6x. 2 times minus 1 is minus 2. Now they're the same, so I'm going to drop them. And just solve the exponent part. So I'm going to move the 2x over, and then I'm going to move that minus 2 over to this side. So negative 10 plus 2 is negative 8. And when I move the 2 over, 6x minus 2 is 4x. Divide both sides by 4. And I get negative 2 equals x. So the goal here really is to make the bases the same, like here and here, so that we can drop them and just worry about solving the exponents and making them equal. Let's go on to some other examples of how you're going to solve some exponential equations on the next page. So sometimes it's not as easy to find a common base. So this is where you might use what's called systematic trial. And so we're going to, basically what we do is we do trial and error. So what you're going to do with this case, to 2 decimal places, is you're going to substitute values in for x and try to see how close you can get. Now, the thing I know with this, that since we have 3x equals 7, is I know that 3 to the 1 equals 3, and I also know that 3 to the 2 equals 9. So I know that my number has to be between, so x is between 1 and 2. So what I start to do is I start to choose values between that, and I just trial and error it. So I'm going to choose 1.5, and I'm going to solve it. So on my calculator, I'm just going to go 3 to the exponent 1.5, and in this case I get 5.19, which means this is too far away, or it's too under, so I need to go over. So then I usually get a little bit closer. So let's try 1.7. And in this case, I get 6.473. So I'm getting closer, but I'm not close enough. So I'll go one more. And this one gives me 7.22, which means I'm over. So now I know it's between 1.7 and 1.8. And so we can get even closer. So I'm going to try 1.75, which is 6.8. Still not close enough. So I'm going to go a little bit higher. 1.78. And it's 7.067. So that's a little bit too high. So now I know it's between 1.75 and 1.78. So I can try 3 to the 1.76, 3 to the 1.77, and you can keep getting closer and closer till you get the answer. 3 to the 1.76 is 6.91, so it's not quite there. 3 to the 1.77 is 6.99. And then you can try 1.771, which is 6.998, which I think is close enough. So I'm going to say that x in this case is 1.771. So that's how you do it with trial and error. Yes, it can be tedious, and yes, you can make a lot of, have to do a lot of guessing or trying it out. It's not hard, it's just tedious. Last example is you can solve this using a graph to 2 decimal places. So actually what I did was I went to www.desmos.com and I graphed it. So I'm going to add the graph here and I'm going to talk about it in just a second. So I'll be right back. So you'll see now I've put the graph in here. On Desmos, when I went to save the graph with the point on it, it wouldn't let me. But if you're actually on Desmos and you click the point here and you just click right there, what happens is it comes up to say that it is, I don't know what's going on here. Hold on, guys. Okay, I fixed it. So if you're on Desmos.com and you push on the point here, what is it doing? If you push on it and it gives you this point, what it actually will come up with is it will say 1.771 and 7. So it will actually, if you click on it, it will give you the point. When I went to save it with the point already there, it didn't want to save the point. So just plot the two graphs. I graphed y equals 3x and I graphed y equals 7. And so this is the y, this is 3x, this was 7. And then so when you click the point, it gives you the point that you want and tells you what it is. So you can actually tell and notice how I got the same value as I did when I did trial and error. So that's how you solve some exponential equations. Try the practice. It's the last lesson in this unit, and I'll see you guys later. Bye.